Welcome back to the SciMax channel. Today I want to show you how we can use OpenCode to create interactive examples you might want for your own personal learning or to use in a lecture to show how something changes as you change a parameter. And we'll use Marimo notebooks. This is an alternative to Jupyter notebooks. It uses a Python script instead of the JSON file, and it has features that allow you to do interactive things, a lot like the Jupyter Notebook. But what I want to show you today is that it's not very difficult to have something like OpenCode or Codex. Any of the coding agents should be able to do this. So the example I want to look at is this reaction network A to B to C, and I want to have an example that sets up the mole balances, solves them, plots the concentration of A, B, and C, and then I should be able to vary the K1 for the first reaction and the K2 for the second reaction, and then have the plots automatically update every time you change it. So we'll look at this as an example, and we'll go ahead and start up OpenCode and see where this gets us. So I just paste in that description and then we'll see where it goes. Now in theory, you could do this again with a widget and Jupyter, but the point here today is that you can have all kinds of things that are generated. We'll generate a Marimo notebook, you can generate a Jupyter notebook, if you want to generate a markdown file, probably even a LaTeX file. Any of those things now are pretty doable, and we choose that Marimo just for something new and to see how it works. So it is going through. You can see it's already creating some Python code in here. It is detecting some errors that it is working through to fix, and it looks like it has basically made one now. It gives me even how to run the notebook, and maybe I'll just ask it to run. I could open a shell and type Marimo edit something. I wonder if I have to click on this. Internal C console. All right, let's see if I have to run it manually. Marimo, edit. All right, so we have a cell to run. Looks like we have the markdown that has the equations. These are the mole balances that are correct. Then we have something to solve. And here we define the sliders. Looks like something is out of bounds. Oh, that's interesting. That's a small error. And then we display them, and we have a nice figure here. So now if I make K1 go bigger, then we'll see that blue line drops down even faster because we are making the reaction that consumes A faster. And if I go from B to C, if I make this faster, then the red line's going to go down and the green line's going to go steeper. So you can play around with this. Seems like everything worked well except for the value here, which didn't take very much effort to fix. So now we have a very reasonable, in under 5 minutes, interactive demo of this series reaction. And you could imagine, you could have parallel reactions. You could have something where you looked at conversion as a function of volume, or some flow rates. There's lots of different kinds of interactive examples that you could make and explore without spending, an hour trying to figure out all the syntax of like how do I stack these and justify this kind of stuff takes ages to work out unless you do it all day every day and it's just something you think about. But I do all kinds of stuff like this all day every day, and that stuff is not in my mind when all I really want is to be able to move a slider bar around and talk about what happens in the results. So that's it for today, and thanks for coming.